To understand the applications of diodes, let us first have a look at the basic working of a diode, which involves forward and reverse bias. In forward bias, positive potential at P repels holes and the negative potential at N repels electrons towards the junction, which in turn makes the diode conduct electricity. In reverse bias, the negative potential at P attracts the holes and the positive potential at N attracts the electrons, preventing their combination at the junction, thus producing high resistance to current flow. This project deals with two basic applications of diodes, rectifier and LED. Rectifier. Electricity and water are very different things, and they flow for different reasons. But there are enough similarities that comparing the two can help you imagine, understand, and remember what is happening in an electrical circuit. A rectifier is an electrical device that converts alternating current, which periodically reverses direction, to a unidirectional direct current, which flows in only one direction. The process is known as rectification. There are two types of rectifiers, half-wave rectifier and full-wave rectifier. First, we'll focus on half-wave rectifier. During the positive half cycle of the input voltage, the polarity of the voltage across the secondary forward biases the diode. As a result, a current flows through the load resistor. The forward biased diode offers a very low resistance, and hence the voltage drop across it is very small. During the negative half cycle of the input voltage, the polarity of the secondary voltage gets reversed. As a result, the diode is reverse biased. Practically no current flows through the circuit, and almost no voltage is developed across the resistor. All input voltage appears across the diode itself. Hence, we conclude that when the input voltage is going through its positive half cycle, output voltage is almost the same as the input voltage, and during the negative half cycle, no voltage is available across the load. This explains the unidirectional pulsating DC waveform obtained as output. Full wave rectifier. A full wave rectifier is a circuit which converts an AC voltage into a pulsating DC voltage using both half cycles of the applied AC voltage. It uses two diodes, of which one conducts during one half cycle while the other conducts during the other half cycle of the applied AC voltage. During the positive half cycle of the input voltage, diode D1 becomes forward biased and D2 becomes reverse biased. Hence, D1 conducts and D2 remains off. The load current flows through D1 and the voltage drop across RL will be equal to the input voltage.